Welcome to the High Efficiency HVAC Solutions for Painting Industry webinar. Let's go check the agenda for today's webinar. I am Luca Brotto, Application Manager for HVAC Industrial Applications at CAREL, and I will tell you about adiabatic humidification and evaporative cooling, while my colleague Paolo Liberati, Business Unit Manager at RECUPERATOR, will introduce you to the plate heat exchangers with their models, options, and a payback time simulation. And our colleague Martin Kohler, Engineering and Consulting Manager, will talk about rotary heat exchangers with their features, operation, and payback time.
Hello, everybody.
If you would like to ask some questions, I invite you to click on the bottom bar of this webinar page, where you should see Q&A. And it's possible to answer a question. We will be able to answer to them during the webinar and at the end when we'll have a couple of minutes for direct questions. Okay, let's start. First chapter, adiabatic humidification and evaporative cooling. We know that humidification and humidity are important for the painting industry, but why? First of all, because paint manufacturers specify the temperature and the humidity correct for the process. The reason is why the coatings behave differently depending on the room temperature and the humidity content of the air. So historically, this has been dealt with by changing slightly the mixture of the paint before spraying, by adding solvents or additives like thinners to the paint. If the temperature and the humidity in the paint input can be kept constant, there is clearly no more need to change the mix of the paint. That could be an operation that leads to human errors. Human errors could also happen because of painter attention that could be lower because of discomfort in the environment. It is pretty common, and there are a lot of studies that testify this subject, that attention and work quality is related to temperature and humidity levels, and they decrease substantially when temperatures are very low or very high, and as well humidity levels are, for example, very low. Finally, humidity contributes to a better painting process because a good level of humidity decreases the static electricity, the dust accumulation and suspension in the air, and the risk of the explosion that derives from the two previous factors. If we talk about liquid coatings, for example, solvent-based coatings, water-based coatings, and high solids coatings, all of them are sprayed with a spray gun. Then happens the paint deposition and coalescence, which means the evaporation of the solvent decreases the liquid content and the pigments stay on the surface. And then these pigments are dried or cured to a complete and finalized coating. Humidity level is very important, especially in the liquid phase, I would say. And optimum levels go from 50% to 70, even 73% in some cases. A low percentage of relative humidity, especially in the paint, in the spraying phase, could lead to dry spray because, for example, the particles that are going out from the nozzle of the gun get dried before reaching the surface. So this could lead to non-uniformous deposition. On the contrary, if humidity is too high, for example, at 80% or higher, it may be then during deposition, the paint is not evaporating rapidly enough, and it can form some runs that go down by gravity. During the coalescence, it may be that the top layer of the paint dries too fast if the humidity is very low, and traps the solvent present in the coating on the bottom level. This can lead to crowfooting or blistering that are defects that compromise the quality of the final product. At the same time, low humidity can also lead to checking, which is basically a loss of opacity of the final result that is visible only the complete curing. It's less easy to think about humidity when doing powder coating, because we are moved to say powder coating is a dry spraying, so it is not influenced by humidity. But it is not exactly correct. In fact, if the humidity is too high, for example, level of 80% relative humidity, could lead to the loss of static electricity of the dust particles, the powder particles of paint that have to reach the target. And this target is grounded so that the particles charged, in this case positively, attach to the surface. Clearly, if the particles lose their static electricity, they will not attach to the surface and will create overspray that will need to be cleaned, filtered, and reworked. Similar, also for low levels of humidity, like 30%, the overspray could increase because on the opposite side, if the static electricity buildup is too strong, these particles may repel each other, not hitting the target anymore because of the too high static electricity. How do we control the level of relative humidity in the air, in the painting booth? By steam humidification or adiabatic humidification. Here you can see a psychrometric diagram with a transformation of heating of the air from winter -5 Celsius degree, 99% relative humidity, to comfort or painting temperature of 22 Celsius degrees, and then a steam humidification from the point B to point D. This humidification is also called isothermal because it doesn't change significantly the temperature of the air and leads to set point. Here, the energy consumed is the one to boil the water, and the power needed to evaporate 1 kilogram of water is around 750 watt. That can be provided by electrical energy or gas. On the other side, adiabatic humidification is the blue line here in the graph from C to D, and is connected to a cooling effect. This is because water is sprayed directly in the air, and to evaporate needs some heat that is absorbed by the air, which in turn gets a little bit cooler. This power needed to evaporate is around 690 watt per kilogram of humidity supplied to the airflow. In winter time, this means that we need to preheat at a higher temperature the air before a humidification. And this is also an opportunity for energy saving, because if we provide this heat through high efficiency systems like heat pumps, we can decrease the realistic energy consumption of the entire system. As well, if we use the adiabatic systems to make evaporative cooling in summertime, we can decrease the temperature inside the painting booth simply by spraying water instead of using mechanical systems. These technologies providing adiabatic humidifications are pretty common in the market. Historically, one of the most known is the wet media, which are usually most common in commercial applications, like for comfort, because they're very easy, not really expensive. They use tap water, but unfortunately they introduce high pressure drops, and they recirculate tap water, which means that could create some bacterial growth and therefore need periodical flushing of water and periodic disinfection and panel replacement. So another technology that has been evaluated over time are air washers that have been often used for washing the air on the exhaust side in wet scrubbing systems for painting booths. They are also used for humidification, and they introduce a medium pressure drop, but they use a lot of water because they produce big droplets that need a lot of time to evaporate. So you need to spray a lot of them. And by using tap water, this system also needs periodic cleaning, draining, and a little bit of wasting of water. As a newer and more advanced system, high pressure humidifiers are used with low pressure drops, treated water, so near to pure water. They don't use recirculation, and they don't need disinfection, and they lead therefore to lower maintenance. Let's have a focus on this technology and understand a little bit better. In this case, we have Humifog, so CAREL high pressure humidifier, which is composed of a pumping station that you can see on the right, with a distribution system inside the air handling unit, controlled by a box that opens and closes valves to deliver the correct amount of flow, and a drop separator, which stops eventually droplets that are not evaporated in the airflow. This system can be made silicone-free, certified with hygienic certification for VDI 6022, and also can be ATEX compliant, thanks to the use of stainless steel material and third-party certifications. It is really important to note, in my opinion, that with one humidifier like this, thanks to a single pump controlled by inverter, it is possible to provide the humidification to up to 12 of these distribution systems on the top that therefore can supply humidity to 12 different booths. So can be really optimized in a term of investment and operation. And for critical applications, like could be 24/7 production and automotive painting, the possibility to use a backup unit to be sure that the system will never stop gives us the possibility to lower the amount of stop of the system, decrease the maintenance, and be sure that it will guarantee a high quality process over time. Also, oil-free pump option is available so that can be the performance of the system can be made longer with less maintenance, up to 8,000 hours of working. It is interesting to note how the humidification, when adiabatic, can lead to cooling. For example, in summertime, without the need to additional investment, because we already have the humidifier in the channel, we can do cooling. As an example, if we have outside air with 30 Celsius degree, with 30% relative humidity, we can spray some water up to 60% relative humidity, for example, which is the target set point for correct painting process, and taking down the temperature down to 23.4 Celsius degree. This can be done as well inside the entire paint shop. And when we spray very fine mist from the top of the building, this has a great advantage because it can suppress the dust that builds up in the air. And it is common to find really fine dust in working environments where, for example, carbon fiber is worked or as well plastics or composite materials. When inside a air handling unit with a cross-flow heat exchangers, for example, it is possible to use not only the humidification and direct evaporative cooling, which would be on the bottom in this part, but also an indirect evaporative cooling system that Paolo also will talk about a little bit more in detail, that can decrease the temperature of the air coming from the exhaust down to the 18 Celsius degrees that you can see here. And in the heat exchanger can cool down the incoming air from outside without exchanging humidity. So you have a cooling thanks to the waste air coming from the unit. And you can supply air with a really small mechanical cooling, which means that you increase the efficiency, lowering the operating cost and also the carbon footprint. The same concept of evaporative cooling can also be applied to chillers when doing mechanical cooling to decrease the energy consumption and to avoid the stop because of really high temperatures that global warming is taking us more and more often. So by spraying water, it is possible to decrease the temperature of the external air going inside the chiller by 5 or even 10 Celsius degrees, depending on the amount of water sprayed, and increasing the overall system efficiency by around 10%, which is greatly affecting the operating costs and the carbon emissions. Now I give the word to Paolo.
Thanks, Luca. Hello to everybody. As Luca already anticipated, there is a component inside the system able to recover energy. This is the heat recovery component, and in specific, one of this type of heat exchanger is the plate heat exchanger. The plate heat exchanger is a heat recovery component, as said, which is made of thin aluminum plates. So let's think about aluminum plates of 0.15-12 millimeter of thickness, so really thin, which are combined together to create air gaps in order to create channels for the two airflows. One is the return air, the other one is the supply air. This package is then assembled together with the casing to create the plate heat exchanger. So as you can see, this is a static component which is installed between the return air and the indoor and the outdoor air in order to recover energy from the chamber towards the supply air. Here you can see on the right a picture of a full fresh air handling unit for the painting cabinet, where there is the plate heat exchanger installed between these two airflows. Then the plate heat exchanger has many features. One, as you have seen, this is a static component, so we don't have any parts in movement. So the cross-contamination is limited almost to 0. So there is no risk of contamination between the extract air towards the supply air. And as you can see in the pictures, you can have a wide range of sizes, geometries, models, and dimension in order to withstand, to comply, to answer to your needs in terms of dimension constraints, so the space that you have, the airflows, the pressure drop, and the efficiency. Talking about efficiency, with the plate heat exchanger, you can have efficiency from 50% up to 80% of temperature efficiency. In this specific application, a really common efficiency is more or less roughly 55–60%. Why not 80? Why not 50? Because there is also a kind of compromise between the efficiency, so the characteristic of the plate heat exchanger, and the maintenance to keep it clean in order to have the best performance out of it. And then also we have the pressure drop, of course, which is a characteristic of a plate heat exchanger, which is the energy lost by the air that is running through the heat exchanger, which could be between 100, 200 Pascal, more or less. And of course, since we don't like in this application at all the fisheye on your painting, all the plate exchanger are silicone free, so there is no silicone at all. Regarding the dimensions, you can have 300 by 300 square plate, where you have then the combination of different plates, and up to a dimension of 2,400 millimeter. So really a wide range, and you can choose among them the best solution for your application, for your conditions. The plate exchanger is a heat recovery component, as said, but sometimes in some conditions where the heat gains inside the chamber are high, for example, or outside it's really cold and you can have condensation in the heat exchanger there, and therefore there is the risk of frosting, you can have a thermal bypass, which is a solution to control the performance of the plate heat exchanger in order to avoid any kind of overheating and to prevent a frost formation. So it's a kind of a system, a gear to control the performance of the plate heat exchanger. The bypass, of course, has to be controlled by a damper. The damper can be delivered with many options. There are many options available. A damper which is aluminum painted, just aluminum made, with internal, external command, central bypass, external bypass, lateral bypass. So there are many solutions that could be in order to answer to your needs. And then talking always about dampers, in some situation, for example, when you change your painting booth between from the painting face towards the oven face, so when you don't need fresh air to control the contaminants, to diminish the contaminants inside the ambient, then you can recirculate the air. So you don't need fresh air, you don't need to recover, but you need the system to recirculate the air. You know probably really well the recirculation damper that is already installed inside your system, but it's really common as well to use the recirculation damper directly on the heat exchanger. So you can save space, you can control, therefore, the recirculation process. As Luca anticipated, with the plate heat exchanger, we can exploit the evaporative cooling without increasing the humidity in the supply side, so in the outdoor airflow. We can do it in a different way with a wet pad, as anticipated. So we wet the air before the heat exchanger, then we go inside with the really cold air, the return air with the high humidity, relative humidity. But we can do better, because if we spray water directly on the heat exchanger, then we exploit more this phenomenon. Since the wetting of the plate is the key to improve the performance of the system, we worked a lot to increase the wettability of the plate. And we developed a coating which is called B-Blue. This B-Blue, as you can see in these three pictures, is able to increase the performance by 35% compared to a standard solution with the wet pad, and 15% compared to a standard solution with the gold epoxy protection, which is the standard epoxy protection for the aluminum plates. The B-Blue coating is available, of course, for all our series, all our geometries and models, in order to support all these type of applications. The B-Blue, to see well how it works, it's a coating on the aluminum, which is hydrophilic, so the relationship between the droplet and the surface is really strong. So the contact angle is much smaller compared to the epoxy protection. But there is another key characteristic, which is the adsorption behavior. Once it is wetted, this plate, as you can see in the second column, starting from the left, the drop that is falling on the surface disappears, creating a thin layer of water. This is the main key, because as you can see in the last column on the right, this drop doesn't disappear because it's the standard epoxy protection. The protection has also another advantage. Since it is a double layer coating, you will have an increase of 50% of your corrosion protection. Maintenance, we said before, it's really important. Such a system, you have dust in the air, you have to clean the heat exchanger quite often, actually. So that's why you are not looking for really high efficiency, because otherwise these air gaps are really narrow. So you have wide fin spacing. Fin spacing, we can say more or less could be 9 millimeter, 10, 11, 8, depending on the size of the plate heat exchanger. But this plate heat exchanger can be delivered in pieces, in slices, let's say, in order to support you in the best way for the maintenance. You have small pieces to handle, you have small pieces to clean, and also to put inside. There are lighter, means faster maintenance. Maintenance can be done easily with water, with the compressed air inside the heat exchanger. But of course, you have to move the heat exchanger from the unit and to put back inside the unit. There is the opportunity to use the side plate that are pended in order to support you in this kind of operation, making easy extraction and really easy handling. Everything was really nice. The plate exchanger is perfect to recover energy. You can control the performance, you can make easy maintenance. But now we have to talk about cost. We have to talk about return on investment and savings. This is an example that we did. Painting booth for care, repair, or industry. Full fresh air with the modulating damper control. So we could control the bypass in order to optimize the heat exchange. This painting booth is in Berlin, Germany. The airflow 20,000 meters cubic per hour. In the painting booth, people work 6 hours per day, so roughly 22,000 hours per year. Efficiency 55, and then the total investment in terms of increasing cost because of the installation of heat recovery is 7,000 euros, more or less. As you can see on the left, there is a chart explaining you the energy consumption for every kind of temperature condition. The behavior, because it's in the every temperature is a sum of every day that has this design condition. So starting from the light red with the heat recovery component, we can decrease the energy consumption by 55%. So we can go down, and we have the red line. Of course, the cooling recovery is really small, because small is the energy requested because of the cooling. And so less energy consumption, what does it mean? In how many months? Because we talk about month, we can have the return on investment. Well, in this case, we're going to have the return on investment within 8 months. So it means that starting from the 9th month, you're going to start to earn money. And if we consider 25 years of using this kind of system, then you're going to save roughly 300,000 euros because just of the installation of the plate exchanger. So this is like a kind of part of a family of a heat recovery component, and the pleasure to leave the stage also to Martin, which is going to talk talk about another kind of heat recovery component. Thank you.
Thank you very much, Luca. Thank you very much, Paolo. Welcome everybody. And now we go into the second part of the heat exchanger solutions for paint shops, which would be rotary heat exchangers. First of all, I just would shortly try to explain how a rotating heat exchanger is working as such, because alternatively to a plate heat exchanger, these units are not static. They need a drive and they are moving. The plate heat exchangers as well as the rotary heat exchangers both need airstream next to each other, so the airstreams must be close. In case of the unit that you see here at the bottom, you would have the old air that is extracting from the building, and the top section would be the fresh air that is coming into the room. The wheel matrix itself is rotating between those two airstreams, and when the extraction air, which is hot, is touching the wheel and the media, just by traveling over it, it will heat up the aluminum. And as the aluminum is revolving, it will per default automatically go towards the cold airstream, which is the upper part. But doing so at this very moment, it is hot. And as the air is traveling over the hot aluminum, the air just simply takes away the heat of the aluminum and will be heated up. So by this application, you can change the temperatures of those two airstreams just by revolving and rotating heat exchanger. By doing so, it is able to do both. It is able to do sensible as well as latent energy recovery. Within a paint shop applications, there are different needs. And for paint shops, we always need to really sit together with the customer and to determine what is needed at the final end. As I mentioned before, we can use sensible and latent heat wheels, so we are able to recover pure temperature applications. We are able to also recover humidity. This all depends slightly on the paint used, on the application, and on the desire of the customer, as well as efficiency is also always an issue and a subject to discuss, as Paolo already mentioned before for the plates. There is to be a compromise to be found between efficiency and the needs of the customer. Based for the rotating heat exchangers, the European regulation ERP 2018 states that we would need to supply 73 to 74% efficiency. Normally, this is too much and too high for a paint shop because you need size, you are really big, and the more efficiency you have, the more cleaning you will need to pay. So from that perspective, the needs on a paint shop normally go down to an efficiency rating of roughly 68% on a heating wheel. As I just mentioned before, the cleaning of the wheel is relatively important because of the color. The paint itself will produce a debris on the wheel, and by doing so, the wheel increases pressure drop, the wheel loses efficiency. So we need to clean the wheel periodically with an automatic cleaning device that is installed onto the heat exchanger. You can see it here on the picture. But this is not only required to keep efficiency as high as possible for the long lifetime. This is also possibly needed for applications where human people are working within the paint shop, because you need to be able to clean the heat exchanger hygienically down to its core, which is possible for a for a rotating heat exchanger because it is relatively small. It has a depth of 200 millimeters, so the water is easily possible to go all the way through. And to clean it, you will see a short video at the end of the presentation. And a very, very nice thing on rotating heat exchangers is that we can deal up to huge air volumes. We can deal with air volumes greater than 200,000 meters cubed for one single air handling unit. And still the installation remains relatively compact because the heat wheel itself is only rising by the surface. So we only need to make the circle bigger, but we do not need to make the depth bigger. So we can keep a relatively narrow air handling unit on the length. And this partly is quite beneficial for size constraints on the job site. Logically, as Paolo already mentioned before, for the plates, silicone-free is a precondition also for the rotating heat exchangers, because otherwise the paint application would just suffer. And same as for the humidification part from Luca, we also are able to fulfill the ATEX compliance, but there's a slight difference. The rotating heat exchanger as a such is not ATEX certified. This only is regarding to electronics that we are able to supply to the customer adapted to ATEX. A typical layout of an air handling unit with a rotating heat exchanger is not that much of a difference to a plate. They are used both in the same arrangement. Anyways, almost most of the paint shop applications, they do have an orientation of the air going top down. As Luca already mentioned, we need to take care of a clean air, so we try to always push the particles, push the dirt downwards, so it is not in the air, but sort of laying on the floor, so it can be easily be blown out in a way. And this is a classical arrangement that is done for any big application like automotive, aviation. People need more or less the same applications to grant a quality of their paint. But this also goes beyond. This goes also towards surface technology. If you take, for instance, the first and the most important thing why heat exchange as a general is super important on those applications, they run 24/7 and they use 24/7 energy to be operated. As I just mentioned before, the big units that we are able to produce, 200,000 meters cube to be dealt with. Logically, the housing has to be adapted. These housings are really heavy duty, strong stability housings. They are not standard. You cannot buy them just from a shelf. These have to be constructed project by project. Same goes for the bypass as for the plates. Also, the rotating heat exchanger is able to be controlled by adding a bypass for efficiency control, for defrosting, for free cooling, to reduce pressure drop on the application in case of no needs of a heat exchanger. And the cleaning itself is needed just to keep the high efficiency during operation, because on a rotating heat exchanger, you can clean during operation. You do not need to stop your production. You can just do it whilst your carrosseries or your cars or whatever you're painting is inside the paint shop. And by cleaning the wheel periodically, the entire efficiency is kept up as high as possible for the entire lifetime, which can be up to 20 years, logically depending a little bit on maintenance, on how you deal with the unit itself. The unit that you see to the left side has been supplied to Mercedes in Düsseldorf, close to our company. And this is a size being 6.60 meters in height and width. But as I mentioned before, the depth remains 0.5 meter roughly, because I don't need the depth, I need the surface on a big wheel. And the wheel itself inside this application is 6 meters in total. The capacity of our production is even possible to produce wheels with a diameter of up to 8,000 millimeters, which would be the biggest units ever built in the market of HVAC units. But how do they get on site? Well, logically, they can be manipulated with cranes. Here you can see an example. This is not really directly a paint shop. It is just a big unit from a data center out of Ireland, but I just wanted to show you that heating wheels are built and produced horizontally as well as vertically, and they can be manipulated on site by using a crane. And they can not only be manipulated by using a crane. In these sizes, you need a crane. So here you just simply can see pictures of an installation in Ireland and how stiff and solid these units are built to be able to be manipulated. If we go further down the route to another project, which has been done in Mecca, this is a project that has been done for a very, very specific application. And you can see here that the housing is 5.75 meters. And because of constraints on sizes on site itself, we needed to produce this certain housing in 5 individual parts to be supplied to the job site. But this is nothing new to us. This is something we deal with every day, because huge units, unfortunately or luckily, depends a bit on the side of the metal, need special applications and need special solutions. The installation of the heating wheel itself is, never mind the size, relatively simple. You can see here that the entire installation is focused on the easiness of access. And as the center of the wheel is the most critical part, you have complete access whilst mounting, whilst commissioning, and logically also whilst maintaining the heat wheel. You have access to the bearing, you have access to the hub, you have access to every little bit of screws, to guarantee that you have an easy access as fast as possible, not to lose time. This is just a little short picture to see a finished mounted unit as well in front of a technician that is just standing there and examining what he needs to do to prepare the air handling, the rotating heat exchanger for the air handling unit. This is a picture of a commissioning done for Airbus. To the left side, it's just another indication of how we produce the product itself. It is mechanically produced in a heavy metal version, so there is nothing weak. Even the back plates of the wheel, the screws of the wheel, everything is done in a very heavy-duty mechanical industrial way, so that the operator has the guarantee that by maintaining it correctly, he's got a 20-year solution inside. Speaking about cleaning, paint is always nasty and paint will always stick on the wheel. And as you can see on those two pictures, there is a huge difference between a dirty wheel covered with paint and a cleaned wheel. This is very self-explanatory to understand that paint is harming efficiency, is harming pressure drop, and logically by all of this is increasing mechanical loads on the wheel, decreasing the lifetime. So cleaning is extremely important. And there are different types of cleaning that we can apply. There is compressed air, there is high pressure water, there's a one-sided cleaning device, there's a two-sided cleaning device. You can clean during operation, and all of which is applied on the air handling unit, no matter the application itself. If you have a wet separation, a dry separation, paint will always be at a certain time on the wheel, and you will need cleaning, and we are able to adapt ourselves to the nastiness of the cleaning if you would like. The cleaning device itself is relatively simple. It is it's just a mechanical part that has a rail and a nozzle for water and a nozzle for air. It's nothing really special. The speciality of it are the two blue boxes, because these are the control units for the cleaning, because they take care that the nozzle is on the exact correct spot at the exact correct time while the wheel is revolving and turning. And we will now be able to see a short video on how this is operating. Here you can see the mechanics installed onto the wheel, and this is also the side where you have the connection to the nozzles. And this part is moving upwards and downwards on the wheel to clean it. Here you can see the water jet that is blowing inside the wheel, and the nozzle are slowly moving from the outside to the inside. And this is the other side of the wheel where you can see two jets of water being blown out into the evacuation tray. The reason why you see two water jets is very simple. There is one water jet that is blowing into the air, into the matrix with 140 bar on pressure. That's the first jet that you see at the exit. But in order to evacuate all of the water, there's a second nozzle, and that nozzle is compressed air. And this compressed air pushes out the rest of the remaining water. So you have a second water jet at the outlet, but you have only one at the inlet. As I just mentioned before, this is where things get a little bit more complex. We need to have a control unit also for the cleaning device itself, because the nozzle needs to be on the correct spot of the matrix at a certain time. We need to guarantee that the speed of the nozzle running around the wheel is constant. So what we need to do is keep the nozzle speed constant, but adapting the revolution speed of the wheel to have the entire surface of the wheel being cleaned correctly. And this is completely done by Klingenburg controls, by Klingenburg personnel during commissioning of the unit. There is no cleaning device that is not commissioned and not built up by Klingenburg. We don't let our customers do it on themselves. We want to do it together with the customer to ensure proper installation, proper functionality, because this is a core component to keep the unit running for 20 years. All of that logically is not given for free. There is a unit, for example, a booth for airplanes in Seattle in the United States, dealing 153,000 meters cube. Slightly different to a plate heat exchangers. The investment cost on a heat exchanger, rotating heat exchanger, is a bit higher. On this example here, we talk about 200 grand. But this includes everything: supply, packing, mounting, installation, cleaning, everything. So this is the final price that you would need to pay to have the wheel running on site. And still, you have a payback time of below 1 year. And if you keep it running for 20 years, if you keep it maintained for 20 years, I think the number itself stands for itself and speaks for itself. $2.7 million US saving over 20 years. If I would be saving as much money for myself, I would stop working and I would be happy for my life. So these are really installations that help our customers to save money. And by the way, it's not just about money. In the future, we all will also speak about CO2 emission, CO2 footprint, all of which simply is just leading towards energy recovery as a such to be very important for paint shop applications. Thank you very much for listening, and thank you very much for your time.
Thanks, Martin, and thanks, everyone. I really think that it's important to take into account not only the efficiency of the systems, but as you said, the maintenance as systems that are meant to work for the entire lifetime of a painting booth can lead to huge savings, not only for the pockets, but also for the climate. And we know that, for example, the automotive industry, as well as the aviation, really have challenging targets to decrease the carbon emissions before 2030 and then 2050, as well as all the industry. I would have a look at the questions and invite our listeners to send us questions regarding both humidification and heat exchangers. Okay, we're already receiving some. We have, what is the air pressure drop for a rotary wheel? Martin, I guess this is for you.
The normal pressure drop would be in the range of 150 to 180 Pascal in a perfect application. 220 would be squeezing out to the max as a standard pressure drop for a brand new wheel. And we recommend to our customers to start cleaning when pressure drop increases by roughly 50%, because this is an indication for the wheel being blocked and being, let's say, ready to be cleaned.
Okay, thanks. And I have a question for Paolo. So, are dampers with ATEX certification available? I guess this is related to the example you have shown of the plate heat exchanger with recirculation. Yes. And yeah, dampers.
Yes, there are, like we said, dampers can have many options. Materials is an option, and also, of course, the ATEX certification is available together with the plate heat exchanger. So yes.
Okay, thanks. Another question is there any risk of contamination mixing both flows with a rotary heat exchanger? And then is there a minimum air velocity? So I guess I can introduce the question, then leave it to the experts. For sure, there is a risk of contamination. It is lower on the cross-flow plate heat exchangers because they don't have moving parts and the two flows are separated. While for rotary heat exchangers, there are specific actions and features to be accounted for when using the recovery. Paolo, Martin, if you want to add something.
Contamination is something that has to be dealt with on rotors, indeed, because of the revolving wheel. There is no hermetic tightness between the two airstreams. So there is, depending on the orientation of the fans, the possibility of contamination. To make it very simple, if your supply air is pulling air through the wheel and the exhaust air is pushing onto the wheel, this is a real bad situation, because then the heat wheel sort of just is an obstacle in the airstream, and the pushing exhaust air will go through the leakage back to supply air. In order to avoid this, there is a technology called purge chamber, and a purge chamber is used to work with the delta P that is resulting out of the fans. And if we have a good orientation and a good made air handling unit, we can prepare calculations that state and grant a carryover effect of 0% EATR. But this needs to be done together with the air handling unit supplier in Klingenburg, because this is not automatically, but it is possible.
Thanks a lot. We have another question. Can the rotative unit be installed horizontally and cleaning is done during the functioning of the boot or not? So actually, these are two questions in one.
Yes, they can. And just to speak out of our daily normal projects, we are just at this very moment working on a job in the UK for Airbus for an installation of 5 horizontal wheels, 5 meters in diameter, including automatic cleaning device. This is normal standard business.
And then the second question was, cleaning is done during the functioning of the booth or not?
It is possible to be done during the operation of the booth. The cleaning device itself needs about 900 liters an hour to be integrated into the wheel, which sounds extremely a lot. But by having the air jet helping the water getting out of the wheel, we have evidence from our customers that the paint shop window in terms of humidity is not past, it's not overdue. So you are still inside the paint shop window for your operation when you start the cleaning device. The delta is in the range of 0.5 to 0.8, maybe 1 gram a kilo, which normally is still something that is not harming the application itself. In brackets, if you're already running at the top limit of the painting window, then it could be an issue, but normally you never do that. Normally you run a little bit below the maximum possible window application.
It looks like questions about the rotary heat exchangers are coming. So what about the VSD for the wheel? Is it an option? The variable speed drive?
It's not an option, it's a must. Very simple. As you said before, the wheel needs to be revolving at a very certain specific speed whilst the cleaning is operating. So I need to have a version, I need to have a controller that is able to control the speed of the wheel while it is cleaned. As I need this anyways for the cleaning application, we also can tell our customers that there is anyways a VSD control unit integrated, included. There are customers who do all of that on their own, but these are customers that are, let's say, heavily specialized on paint shop applications, and they don't do anything else. One of those would be Eisenmann or Dürr. With those guys, partly we do not supply a VSD, but for 80% of all the paint shops, we supply a VSD.
Okay. One last question. How do you deal with frost risk in plate heat exchangers and rotary heat exchangers? So Paolo, please, first.
Yes, with regarding the plate heat exchanger, to control the frost formation, where to avoid the frost formation, you can work on the temperature across the heat exchanger, and then you can control the temperature, the mean temperature of the plate, thanks to the bypass and controlling the damper. Of course, the damper can be controlled with the on-off driver, but also with the modulating driver in order to optimize as much as you can the right airflow to avoid any kind of frost formation. Because avoiding is request less energy. It's less energy than the defrosting itself. So it's better to avoid it to prevent the frost formation instead to melt the frost formed on the heat exchanger.
And what about the rotary, Martin?
The regulation using bypasses would be identical to what Paolo just said. And I just have to add, it is always very important to counteract icing before it takes place, because the problem for icing is it's not the first ice that is on the plate, but it's the glaciering. The very second there is ice on a surface and there is water added to it, the speed of the ice building up increases dramatically. This is one of the reasons why you also have, let's say, glaciers in a climate zone in the Alps where it is +3 degrees, but you still have the Alps and the ice and everything. So I must say the same thing. Avoid icing before it takes place. The easiest way is by increasing supplier temperature brackets. That's the most expensive way. The best way would be using bypasses to control the efficiency of the heat exchanger, or if bypasses are not available to control the efficiency of a heat exchanger, use the VSD. Because as we have the VSD anyways for the cleaning and for other reasons, the VSD is able to reduce the speed of the wheel down to a very, very slow revolution speed of something like 0.5 revolutions per minute, which is extremely slow. And by reducing the speed of the wheel, we kill its efficiency. But the positive thing is sensible efficiency is killed a lot lesser than latent efficiency. So by reducing the speed of the wheel, you still remain in the range of 60 to 70% of your max temperature efficiency, but you go down to something like 10, 12, 15% of latent efficiency. And if latent efficiency is almost not given, then you also do not have any frost risk.
Okay, clear, thanks. There is also another question, and it's about the humidification part. So that's for me. What is the water particle size with humifog? With humifog, that is a high pressure humidifier, the droplet size is average around 15 micrometers. So it ranges mainly from 10 micrometers to 18, let's say, micrometers. And this is allowing water to evaporate in really short distances. For this reason, most of the technologies using high pressure pumps set the working pressure around 70 bar, because that's the perfect point to have small droplets without increasing too much the pressure and therefore energy consumption. Thanks a lot, and we are available for contacting if you have further questions. You will receive the presentation as a feedback email in next week, actually. And also the link to download the new white paper about the painting application that will deal with humidification and heat recovery, and also controlling of these components inside the air handling units and for paint shops. So really look forward to get in touch with you, and thanks again for attending to our webinar.
Thank you. It's been a pleasure.
Thank you very much. Thank you very much.